In the problem, we're told that a hairdryer has a power rating of 1,000 watts, and we're asked to find how much electric current passes through the dryer when it's in use, and what is the hairdryer's resistance. So we have two mathematical relationships that govern these electric circuit characteristics. The electric power is equal to the product of voltage and current, and electric current is the voltage divided by the resistance. So if we want to answer the question, how much current is our hairdryer using, we can use the first relationship of power, voltage, and current. If I divide both sides by voltage, I get that current equals electric power divided by voltage. If I plug in 1,000 watts and divide by the typical voltage in an electric circuit of 120 volts, I'll get my answer. And 1,000 divided by 120 is in fact 8 1/3 amps, or 8.3 if you prefer. For the second part of the question, when we want to know the resistance, there's actually a couple of ways to do it. We know the current here, so we could use Ohm's law. But you can also plug in Ohm's law to the power relationship and find power in terms of voltage and resistance or current and resistance. I'm going to do the first method that I suggested, but if you poke around on the internet, you can easily find the other electric power relationships that relate power, voltage, and resistance, or power, current, and resistance. So how much resistance does my hairdryer have? Well, current equals voltage divided by resistance. So if I multiply both sides by resistance and divide both sides by current, I'll get a relationship that says resistance is equal to voltage divided by current. And if I plug in my numbers, again assuming 120 volt outlet, and now the 8 1/3 amps of current that we just found, we can work out what that is. So 120 divided by 8 and I'll just throw in a few threes here. That gives me my resistance of 14.4 ohms. Often you see that written with the Greek letter omega.